So now we will discuss color limits and extensions. Matplotlib allows for a large range of color bar customization. The color bar itself is simply an instance of plt.access, so all of the access and tick formatting tricks we have learned are applicable. The color bar has some interesting flexibility. For example, we can narrow the color limits and indicate the out of bounds values within a triangular arrow at the top and bottom by setting the extend property. This might come in handy, for example, if you're displaying an image that is subject to noise. Now, make noise in 1% of the image pixels. Now speckles and p dot random I dot 0.01 speckles and p dot random dot normal 3 and p dot count speckles. Now plt dot figure fig size 3.5 plt subplot to plt dot imshow cmap is equals to rdbu. Now plt dot color bar. Now plt dot subplot to now plt dot imshow cmap is equals to rdbu plt dot color bar extend both plt dot clin minus 1. Now we have speckles less p dot count on 0. So we have no comma here actually. So we have this. So notice that in the left panel, the default color limits respond to the noisy pixel, and the range of the noise completely washes out the pattern we are interested in. In the right panel, we manually set the color limits and add extensions to indicate values that are above or below those limits. The result is a much more useful visualization of our data. Now we will discuss discrete color bars. Color maps are by default continuous, but sometimes you'd like to represent discrete values. The easiest way to do this is to use the plt.cm.get underscore cmap functions and pass the name of a suitable color map along with the number of desired bins. plt dot imshow cmap plt dot cm dot get cmap. Sorry. plt dot plt So the discrete version of the color map can be used just like any other color map.